Okay, guys, so we're going to go ahead and go over the back page of this now. Um, so I want you to make sure that you've given this thing a shot before you start watching this video. So if you haven't finished all of the backside, don't start watching the video. I want you to make sure that you try it before you watch this. This is your checking your answers right now. Um, so A says, how does the motion of cyclist A in the graph compare to that of A in the previous graph? So if I look at A and I see A is right here, well, it's generally uphill. Let's see, we can kind of go back and look here compared to A there. I think it's probably safe to say that it's about exactly the same. So I'm just going to write that in. Exactly the same. Sorry, that's bad grammar. It's okay. This is science, not English. How does the motion of cyclist B compare to that of B in the previous graph? Well, we see that B is going to be pretty different. So B here is actually going downhill, whereas B here went uphill. So that's a pretty big difference. So let's go ahead and write that in. The biggest difference here is that B is now downhill, and that's important. That really changes what's going on, because if we think about it, I don't think they asked this question. So if we think about what that means, A is going one direction, well, B is going the opposite direction. So we can think of them as starting at two different points and actually riding towards each other here. So that's what's going on. A is going away from the 0 point, B is going towards the 0 point, and they're going to cross paths at some point. So we'll see how that works for the rest of this time. Oops. Which cyclist has the greater speed? How do you know? Okay, so we need to compare the slope. And here it doesn't matter if it's positive or negative. We just want to know the absolute value of the slope. So here's how I look at this, guys. I'm going to go ahead and I'm going to zoom in. I'm going to erase those. Now, when I look at this, I notice that I've got a nice point here and I've got a nice point here. So we can compare the speed at those two spots. So let's think about rise over run. We know that this is 8, 10, this is 12 seconds. So let's think about how far, regardless of distance, how far does each one go in that 12 seconds? And let's just pretend that this is 1 meter for each space. This is a bad graph, no labels. So for A, in 12 seconds, it goes 1, 2, 3, 4, 5, 6, 7 meters in 12 seconds. So rise over run would be 7 over 12. Okay. For B, it goes 1, 2, 3, 4, 5. 5 meters in 12 seconds. So it's 5 over 12. So it's actually negative 5 over 12, but that's okay because we're not worried about negatives. We see that the absolute value, the bigger one, is 7 over 12. It goes farther in the same amount of time. So that means that A is faster. This has a neat little trick actually here, guys. This is Notability. If you have an iPad, it's a great app. Okay. A is faster, and we know that it goes farther in same time. There we go. Okay. A is faster, it goes farther in the same time. Sorry, that is really messy looking. It's okay. Describe what's happening at the intersection of lines A and B, all right? So let's erase all this stuff off of here. So what's happening right here? Well, it's the exact same, guys. That's the point where they have the same position. So whenever two lines have the same position, that means that they're right next to each other. So we're going to say A is passing B. They're passing by each other, okay? They're in the same spot. They're right next to each other. Okay, which cyclist traveled a greater distance during the first 5 seconds? Well, we can go look at the graph here, guys. That's fine. Let's look at the graph. And we can see, all right, well, 2, 4, so 5 seconds is about here. All right, so who went farther? You know, it looks like B went, about 2 meters, whereas A went about 3 meters. So we can go ahead and we can say A went farther. But we wouldn't even have had to have looked at the graph. If A is faster, then it goes farther in 5 seconds. So we can just go ahead and say that. A, here, let me use my little handy dandy box here. So A, because it's faster. That's how we know. It doesn't even matter what it says on the graph. We just know it goes farther because it's faster. Okay, so finally it wants a motion diagram. Here's the last part. So the motion diagram is going to look similar to the first page in a lot of ways. And so let's just go ahead and draw A first. So we knew that A was red. And when we look up at the graph, oh no, A is blue. That's cool. We can do A is blue. Okay, we look up at the graph. And okay, so A is traveling away from 0. And we know that it's a little bit faster than B. All right, so we go ahead and let's put our dots in. So fast means the dots are going to be fairly far apart. Okay. And it's traveling to the right, away from 0. Now let's do B. Now B, we know it's going a little slower, so the dot should be a little bit closer. But the really important thing here is that it's traveling the opposite direction. So now I've got my dots that are closer together, but I'm also going to draw my arrows in going the other way. So now I can see that my blue line goes to the right, and it's fast. My red line goes to the left, and it's slow. And there we go, guys. That's the end of the theoretical lab. Again, if you need to go back, scroll back on YouTube, you can watch parts of this again and make sure that you understand it really well. Thanks for working hard for the subject today, guys. I will see you tomorrow.